We have given continuous function in closed interval from 0 to 4. To find absolute maximum and absolute minimum, we need to find critical numbers. And when we have critical numbers, we have to find the value for these critical numbers for our function and the value of our endpoints. So for 0 and for 4. When we have these values, we have to choose the largest and the smallest. So we will have absolute maximum and the absolute minimum. So first, I will rewrite our function h to power 4 because it's easier to find derivative. So h of t is equal t times, in parentheses we will have t squared minus 9 to power 1 over 3 because we have cube here. So now we will use the product rule to find the derivative. So u times v prime is equal v times u prime plus u times v prime. In our case, we have u equals t and v is equal t squared minus 9 to power 1 over 3. So first derivative h prime of t is equal, we have to copy first this whole expression, so we have t squared minus 9 to power 1 over 3 times derivative of t is 1 plus, now we have t times derivative of this whole expression, so we have to first take down this power, so it will be 1/3 times this whole expression in parentheses, so we have t squared minus 9 to power 1/3 minus 1, and we have to multiply by the derivative of this whole expression inside parentheses. So derivative of t squared is 2t, and minus derivative of 9 is 0, we don't have to write. So this is equal 1 times this whole expression, so we have t squared minus 9 only to power 1/3. And here we have t times t squared, and 1/3 times 2 is 2/3 times t squared times t squared minus 9 to power negative 2 over 3, because 1/3 minus 1 is negative 2 over 3. So now we can factorize t squared minus 9 to power 1/3, so it will be, from first expression we have only 1, plus will be 2 over 3 t squared times t squared minus 9 to power will be negative 1. Close parentheses. Why negative 1? Because when we have the same base, when we multiply two expressions with the same base, we add exponent. So 1/3 plus negative 1 is negative 2 over 3. It's the same what we have at the beginning. It doesn't change anything. So this is equal, we have t squared minus 9 to power 1/3, and in parentheses, because we have negative power, I have to put this whole expression to denominator. So first we have 1 plus, in numerator we can put 2t squared over 3 times t squared minus 9 to first power, we don't have to write, so I have to close parentheses. So this is equal, because I have fraction in the second expression in parentheses, I will change 1 to fraction. The common denominator will be 3 times t squared minus 9. So let me copy this, the beginning, t squared minus 9 to power 1/3. The common denominator will be 3 times t squared minus 9 when I multiply 3 times t squared minus 9 is 3 times t squared minus 9 plus 2t squared. So this is equal, I can put in parentheses this whole expression. This is equal t squared minus 9 to power 1/3, and in numerator we will have t, 3 times t squared will be 3 squared minus 3 times negative 9 is negative 27. So 3t squared plus 2t squared is 5t squared minus 27 over 3 times t squared minus 9. So this is my first derivative of our h function. When I'm looking for critical numbers, I have to check the domain of our function h prime. Because we have fraction here, we know that we cannot have 0 in denominator. And this denominator will be 0 for t equals 3 and t equals negative 3. But we see that negative 3 doesn't belong to our domain of our function. So we have to only consider t equals 3. Because for t equals 3, our h prime function of 3 is undefined. It means doesn't exist. So it means t equals 3 is our first critical value. Why I didn't take negative 3? Because negative 3 doesn't belong to domain of our function. Now we have to set our first derivative equals 0. H prime of t is equal 0 if and only if we have t squared minus 9 to power 1/3 times we have 5 t squared minus 27 over 3 times t squared minus 9 is equal 0. Because we have multiplication, so we have two equations. T squared minus 9 to power 1/3 is equal 0, or this whole expression, so we have 5 t squared minus 27 over 3 times t squared minus 9 is equal 0. So because I have here power 1/3, I will take both sides to third power, so this power we reduce, so we have only t squared minus 9 is equal 0 to power third is still 0. So t is equal plus minus 3. And here we have fraction. Denominator cannot be 0, so we have to only take numerator. 5t squared minus 27 is equal 0. I will move negative 27 to the right side. 5t squared equals 27. Now we divide by 5. 5 and 5 we reduce. And we have t squared is equal 27 over 5. So t is equal plus minus square root of 27 over 5. So this is equal, let's use calculator. We have square root of, in parentheses, 27 divided by 5. This is equal plus minus 2.32. So we got 4 solutions. Positive, negative 2.32, and positive negative 3. Now we have to check if R belongs to domain of our function. The domain is interval from 0 to 4, so it means we cannot consider negative values. So we have only t equals 3 and t equals 2.32. These values are our critical points. But because we have already 3, positive 3, so we have to take only once this 3. Now we have to calculate the value of our function for these critical points. So we have h of 3, h of 2.32, and the endpoints is 0 and 4. So h of 0 we have to find and h of 4. So this is equal. We have to replace in our general formula t's by 3 first. So we have 3 times cube of 3 to second power minus 9. This is equal 0 because 3 to second power is 9. 9 minus 9 is 0. Cube of 0 is 0 times 3 is 0. And here we have 2.32 times cube of 2.32 to second power minus 9. So this is equal, we can use calculator. So it will be 2.32 times cube of, open parenthesis, 2.32 to second power minus 9, close parenthesis. This is equal negative 3.56. And now value for 0 will be 0 times cube of 0 to second minus 9. This is equal, of course, 0. Now we have 4 times cube of 4 to second power minus 9. This is equal 4 times cube of 16 minus 9 is 7. So this is equal 4 times cube of 7. This is equal 7.65. Now we have to choose the largest value. The largest value is 7.65, so this is our absolute maximum. And the smallest is negative 3.56, so this is our absolute minimum. So this is my solution.